So in the last video we finished by defining a new function called the absolute value function. And so I want to actually do a more formal definition for you now. We said intuitively that the absolute value is a distance function. But let's see how that works. So definition. The absolute value of x is denoted by bars for x, and so it's going to be x if x is greater than or equal to 0, or minus x if x is negative. Okay, so for example, the absolute value of minus 3 would be 3, the absolute value of 2 is 2, the absolute value of 0 is 0, and so on. Good. Okay, so now how would we graph this function? Well, this is a piecewise function. If x is greater than or equal to 0 means that you're over on this side of the axis. And in that case, then y is just x. So let's see if I can plot that. Here's y equals x. Okay, and then if x is negative on this side of the axis, you have negative x. And so the function would look like that. And so we get the infamous v function. This is the absolute value function here. It's the v. Okay. Now, how would we define something like y equals the absolute value of x minus 2? Well, we take the same, we take the same definition here. It's going to be x minus 2 if x minus 2 is greater than or equal to 0, or it's going to be minus x minus 2 if x minus 2 is negative. So don't leave it in this form. We want to simplify that a little bit. That is, we have x minus 2 if x is greater than or equal to 2, and then we have minus x plus 2 if x is less than 2. Good. And so this is the way you would write that. And so notice that that's just really shifting our function over 2 units to the right. And so our function now would look like, where is my 0? That x equals 2. And then we have our v shape. Oops. It's 45 degrees here and here. Okay. Good. And so similarly, how would we graph something like y equals the absolute value of, how about x squared minus 1? Well, before we do this algebraically, let's see if we can figure out what it is graphically. So the way I'm going to start is by looking at just x squared. And so hopefully you remember y equals x squared is just going to be a parabola, right? So this is y equals x squared. And then what happens when we subtract 1 from x squared? That just brings the parabola down 1 unit. Oops, sorry about my drawing. So that's now y equals x squared minus 1 equals x squared minus 1. Good. And now when I take the absolute value, whoops, what's going to happen? I'm going to draw the result in white. Well, these y values are positive, so they stay exactly the same. The y values in here are negative, so we're going to take the negative of that, and so that's going to create this function, right? So that's going to flip these values up, and then we'll have this function here. Okay, and so we see, let's see, this is equal to 0 at minus 1 and 1. So we see that the absolute value of x squared minus 1 is equal to positive x squared minus 1 if, where did we not change the graph? Here and here. So if x is less than or equal to minus 1, or x is greater than or equal to 1, and then it was minus x squared minus 1 if we had x between 1 and 1. Oops, I shouldn't have double definitions there, although it doesn't really matter which ones you assign. Good. And so, yeah, so that's kind of fun to draw the pictures of that. And so we could get rid of the red part. And probably that too. Whoops. Okay, that's the graph. All right. Let's see. One last thing I wanted to mention is, let's see if we can do sine. Let's see if we can, what am I trying to say? Do interval analysis. Interval analysis. And so by that I mean, how would you solve the following? Like x squared minus 5x plus 6 is less than or equal to 0. We could do it geometrically like we did up here, but that can be kind of difficult. It's probably easier if we can factor that. So if we factor that, that's x minus 2 times x minus 3 is less than or equal to 0. And now if we look at this expression, what different ways are there of getting this product to be negative? Well, either x minus 2 is negative and x minus 3 is positive, or vice versa, x minus 2 is positive and then x minus 3 is negative, so one of those is negative and the other is positive. Is there any other way of getting it? Because if they're both negative, they would be positive. Okay, so there's lots of different ways of looking at that. So an easy way of kind of organizing your thoughts for this is to build what we're going to call a sign chart. And so I'm going to write x minus 2 and x minus 3 off to one side here. I'm going to write the number line down below. And then down below here, I'm going to write where each of these factors is equal to 0. Okay, and now I'm going to write where each of these factors is positive or negative. So if x is less than 2, then this is going to be, so for example, 0 would make this first expression negative, and then it becomes positive, and then it stays positive, right? Similarly for this expression, if I put in a number less than 2, for example 0, this is negative. And then if I put in a number between 2 and 3, so for example, what's a number between 2 and 3? 2.5. 2.5 minus 3 is still negative. And then this is going to be positive. And so we see from this number line that there's only one solution here. The solution is where x is between or equal to 2 or 3. And so that is our solution. Okay, so this is called a sign chart analysis. And so maybe we should do one more just to make sure that we get it. So I'm going to write down an expression we want to solve for x. If we have x times x minus 1 times x plus 4 is greater than 0. And so go ahead and pause the video for a moment and see if you can solve for x. Okay, are you back? So using the sign chart, we write down our factors to one side. We write down a number line. And now on the number line, we write down where each expression is equal to 0. So the first one is 0 at 0. Second one is 0 at x equals 1. And then the third one is 0 at x equals minus 4. Okay, and now that separates our number line into 4 regions, right? And so we go through and we put a sign, SIGN, in each of the regions. So x is negative here, here, positive, positive. Similarly, x is negative, 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 positive. Right? And then negative, positive, positive, positive. Good. And now this makes the problem a lot easier, right? Because now if we multiply these three numbers together over here, that would be positive times positive times positive, which is positive. And so this is a good region. If I am in this region, I multiply positive times negative. That's our product is negative. And then here, it's going to be negative times positive. So that's positive. And so that's part of my solution as well. So this is my solution. X is between minus 4 and 0, or x is greater than, is that a 1? I believe so. There it is. Very good. And we're up to our 10-minute self-imposed restriction here. So I will be back with one more point. I just wanted to talk about one more thing before we actually stop for the day. So I'll try to make that short. See you then.